Well, hello everyone, and welcome to the lesson 23-2 practice. We're on page 323 in our text. Pretty short lesson, only a page and a half, but a lot of information and a lot of work to be had. So definitely great to have you here because this information can be rather intense, especially if there's any lingering misunderstandings going on here. So we're going to start with item 7. Given triangle ABC with the measure of angle A is 70 degrees, BC is 85, AB is 88. Find two possible values for each measure. So I do want to just go and insert here, even though they don't ask for it, there will be two possible measures for the measure of angle B, even though they don't ask for it in this problem. So we're actually going to do this work way up here at the top because I have no room on this page to do it. So given triangle ABC with measure of angle A 70 degrees. So I'm simply going to sketch what possibly a 70-degree angle could look like. And they tell us the distance from A to B is 88. So if A is here, we'll just say that B is 88 units along that path there. So somewhere up here. And the distance from B to C is 85. So again, we have two possibilities, assuming if it's, we'll say this is 85 units and C could be here, which means that this is now the length of AC, or we can draw it again. I'll try to match it, 70 degrees. Again, still the distance from A to B is 88, but the length from B to C being 85, we could actually rotate that measure, that length, such that C is now an acute angle. C is now an obtuse angle, so that this is still 85 degrees. So I'll label that B, we'll label this C. Again, it's the two possibilities based on the ambiguous case of the law of sines. And it's because of side-side angle. That's the issue here. It all goes back to what we learned about triangle congruencies. So we need to find the measure of angle C, and then we'll of course have to find the measure of angle B so that we can find the length of AC, which is the side opposite of angle B. So I'm going to do some labeling here. So opposite of vertex C is lowercase c. Opposite of vertex A is lowercase a. And of course, this side will be lowercase b. I'll just put it inside the triangle so we don't get confused here. So go back and label the second triangle here. I don't know why I put a degree symbol. I guess it's such a large number, I just assume it's a degree, but that's not a degree. So now we have everything labeled, and our first task is to find the measure of angle C. And that's great that they tell us to find the measure of angle C, but we need to understand why we should find that angle first. Well, we're definitely going to use the sine of angle A and its opposite side because we know the measure of angle A and its opposite side. But why should we find angle C first? Well, we know the length of its opposite side, so we can find that angle knowing the length of its opposite side. So we're going to use the sine of A, which will be the sine of 70 degrees over its opposite side, which is 85, equal to the sine of C, which we don't know, over its opposite side, which we do know is 88. So we're going to cross multiply here. So we'll get 85 times the sine of C. And I apologize, I'm running out of room, so it's rather narrow, equal to 88 times the sine. Wow, that looks terrible. 88 times the sine of 70. Hopefully you're listening, not just reading, because that looks pretty awful. And so this is 85 times the sine of C. We're now going to divide both sides by 85. And I'll clean this up a little bit. Of course, if this is 85 times the sine of C and we divide this side by 85, the 85s will cancel. So I'm left with the sine of C equal to 88 times the sine of 70 degrees. A little bit better to read, over 85. Now, at this point, again, if we're trying to find the measure of an angle, we're going to use the inverse trig function. And we've really just been focusing on the sine function because it's called the law of sines. So the sine inverse of this ratio, sine of 70 degrees over 85. And I did keep calling a ratio because all a ratio is a fraction comparing two numbers. And this will evaluate to a number. 88 times the sine of 70 will be a number. And this is obviously a number. So it's the inverse trig function of that ratio, which will give us angle C. And we'll go and say we'll round to the nearest degree, even though they don't tell us to specifically. So 88 times the sine of 70 over 85. So we'll use the inverse sine function. And I'll use extra parentheses, 88 times the sine of, a lot of numbers here, sine of 70, close parentheses, over 85. And we get 76.6. Just for the sake of continuing what we did in our actual lesson, we'll use that 10th, the 6th and the 10th place to round the 76 up to 77. So angle C could be 77 degrees, or recall from the lesson, there's another possibility for angle C. So we'll go and add that down here. The measure of angle C could be 77 degrees, or the measure of angle C could be, and the way we find that is we simply take 180 minus 77, and we get 103. So again, there's one acute and one obtuse, and the reason being the sine of 77 degrees is equal to the sine of 103 degrees. So the measure of angle C here could be 103 degrees, which now that we know a second measure of an angle in these triangles, we can find angle B, which is the whole point of finding angle C, to be honest. So let's find angle B. Now, angle B in this acute triangle, we'll take 180 minus 70 minus 77, and we'll get 33 degrees. And then we'll take 180 minus 70 minus 103, and we'll get 7 degrees. So again, there's two possibilities for angle B, 33 degrees and 7 degrees, which means there's two possibilities for the length of its opposite side, AC, which we labeled lowercase b. So now we're going to find the length of those two possible sides using the law of sines. So we're going to continue using the sine of A over its opposite side because those two measures we were actually given and we didn't have to round those. You wouldn't be wrong if you use the sine of C, but again, that was very much a rounded answer. It's actually closer to 76.6 than 77. So we'll use the sine of C over C equal to the sine of B, now that we know the measure of angle B, over its opposite side B. Now, for the sake of the practice, because we actually saw where it came from in the lesson, I'm going to go and write two different ratios using the two different angles for B. So the sine of C, capital C, or excuse me, sine of A, I'm saying one thing, writing another. So we're actually going to go back and use A, again, because we didn't have to round. Those were given measures. So we'll replace A, angle A with 70 degrees, its opposite side, 85, equal to sine of B for this first triangle would be the sine of 33 degrees over its opposite side, which we don't know, or I'm going to go and write it here right next to it, sine of 70 degrees over 85 equal to the sine of 7 degrees over B. So again, based on whichever angle we decide to go with, or based on whatever angle C was, we have two different proportions here. So now we'll use cross multiplication here. So we'll get B times the sine of 70 degrees equal to 85 times the sine of 33 degrees. And since that's b times the sine of 70, we'll divide both sides by the sine of 70 degrees to solve for b. Of course, the sine of 70 degrees will cancel on this side, and we'll have b equal to 85 times the sine of 33 degrees over the sine of 70 degrees. And I'm not going to show this middle step here because the only thing that changed from this proportion and this proportion is that angle B was 7 degrees or 33 degrees. So I'm simply going to rewrite this equation and substitute 33 degrees with 7. So 85 times the sine of, almost wrote it, sine of 7 degrees over sine of 70 degrees is our other possibility for B, which is the length of AC. So B will approximately B will approximately B. Let's do some figuring. So I do want to make this point right here. Since we're not finding an angle measure, we are not going to use the inverse trig function. So we're just going to use these trig functions as they are. So we'll use parentheses, 85 times the sine of 33. We'll start with that one, divided by the sine of 70. And we'll find the other value, 85 times the sine of 7 degrees divided by the sine of 70. So rounded to the nearest tenth, we've been rounding our angle measures to the nearest whole degree and rounding our side lengths to the nearest tenth. So if the measure of angle B is 33 degrees, then its opposite side is 49.3. So we'll go and add that because the 6 rounds the 2 up. And if the measure of angle B is 7 degrees, the measure of its opposite side is simply 11.0. So the two possibilities for AC, again, assuming the measure of angle C is 77 degrees, then AC is 49.3, or, and I like writing it kind of as these two columns here. So if the measure of angle C was 77 degrees, the length of AC is 49.3. And if the measure of angle C was 103 degrees, the measure of AC, which again we labeled lowercase b, is 11. So starting to get the hang of the process here. But again, we don't just want to kind of go through the motions. We want to understand why we're doing the math that we're doing, because it helps us deepen our understanding of the math in general when we see it later, and why we decide to use law of sines over other methods. And especially as we push forward in lesson 23-3, when we discover something called the law of cosine. So we need to just not memorize the process. We need to understand why we're using the process we are. So now let's take a look at item 8. So on item 8, we are given, very similar to item 7, triangle ABC with the measure of angle A equaling 40 degrees, BC equals 26, and AB equals 32. And again, it says find 2 possible values for each measure. So we're going to repeat the process just like we did on 7, and this helps us just again solidify the steps involved. But as I said before, we need to make sure we understand why we're taking these steps. So up here, we'll kind of draw a little line just to have a break in it. So if we have some angle A, which they tell us is 40 degrees, and the distance from A to B is 32. So if A is here, then the distance along this ray will stop somewhere saying that this is 32. And if BC is 26, just like we saw in the previous problem, and just like we saw in the lesson, there are actually 2 choices, 2 ways we could draw BC so that the length of BC is 26. So we could either draw it such that it creates an acute triangle, again, along the path that A was on, along that ray, all the way to C. Or we can draw it again, very similar, just like we did on the previous problem. Let's draw that 40-degree angle again. Same way with AB being 32. But now BC could still be 26, but instead of creating this acute triangle going at this slope, if you will, calling it that slope, we could actually do it I wouldn't say it's the opposite slope, but it might actually be the negative reciprocal. So the length of BC still could be 26 and create what looks like an obtuse triangle. So again, based on what we're seeing with the law of sines, the ambiguous case, there are two possibilities based on the measures that they gave us. So our first task is to find the measure of angle C. And again, it's either going to be an acute angle or an obtuse angle. So we're going to use the law of sines here, obviously. This is lesson 23-2 practice. So on this one, just like the previous problem, we are going to use the sine of A compared to its opposite side. So let's go and label that opposite of vertex A, this 26 is lowercase a. Opposite of vertex C, we're calling this lowercase c, and this side we don't know, B, and we'll do the same thing on this other triangle. This is A, opposite of vertex C is lowercase c, and this is B. So we're definitely going to use the sine of A here because we have the complete proportion or complete ratio in the law of sines for angle A. So we'll say that the sine of A, which angle A is 40 degrees, over its opposite side, which is 26, is equal to, now if we're looking for angle C, we definitely should use the sine of C, and that's good that we're looking for angle C first because we know the measure of its opposite side. We could not have found angle B first because we don't know its opposite side, and we'd have two missing values in our proportion. So we definitely want to use the sine of C because we have its opposite side length, which is 32. Cross multiply here. So we're going to have 26 times the sine of C equal to 32 times the sine of 40. Apologize, running out of room there, pretty awful. And then to solve for, or at least get sine of C by itself, we're going to divide both sides by 26. So that it cancels out here on the left side. And we're left with the sine of C equals 32 times the sine of 40 degrees over 26. And just like we saw above and what we learned in our previous lessons in activity 22, to find the measure of an angle, we're going to use the inverse function. So we're going to take the sine inverse of this ratio, 32 times the sine of 40 over 26. And we're going to find C is approximately, or angle C. So let's run over to Desmos real quick. Sine inverse of 32 sine of 40. So we're going to use the sine inverse. Just open another parentheses for those using the TI-83. 32 sine of 40, or 32 times the sine of 40. Close parentheses, divided by, let me just make sure, divided by 26. Let me make sure I'm in degree mode, need to change that. And we get 52.29, 52.29, which I believe we are rounding to the nearest whole degree here. So 52.29, that 2 will tell the other 2 to stay where it is. So we just found that the measure of angle C is 52 degrees. So we can go and write that in here, or at least in one of our possible outcomes, it is 52 degrees. So now we need to find the other possible measure for angle C in our obtuse triangle. And again, the way we do that is we take 180 degrees and subtract 52. And we find that our other possible angle for angle C is 128 degrees. So we could have the measure of angle C equal to 52 degrees, or the measure of angle C could equal 128 degrees. Now, depending on what we're saying the measure of angle C is, largely determines angle B. So let's go and find the value of angle B. So if these two angles, if this is 40 and 52, we're going to take 180, subtract 40, subtract 52, and we find a possible angle measure for B is 88 degrees. And we'll do that likewise down here. Now we'll take 180, subtract 40 again, but now subtract our other possible angle measure, 128, and we get angle B is 12 degrees. So now we have two possibilities for angle B, just like we have two possibilities for angle C. And now we're going to find the side opposite of angle B, which is AC, which we've labeled lowercase b. Now I encourage again here, let's definitely use the sine of A as well, because we didn't have to round these values like we did for angle B and angle C. So definitely use the sine of A here. So the sine of 40 degrees over its opposite side, which is 26 in both cases, equal to, now we have the angle measure for B, so we're going to do we'll actually do this top one here, the sine of 88 degrees over its opposite side B. And we'll replace it with 12 degrees at the end, just like we did on the previous problem. We know that all we're doing is switching out that measure right there, 88 for 12. So we'll do that at the very end. So now let's cross multiply. We'll get 26 times the sine of 88 degrees equal to B times the sine of 40 degrees. And to solve for B, since this is B times the sine of 40, we're going to divide both sides by the sine of 40 degrees. So divide by the sine of 40 degrees. So B is going to equal 26 times the sine of 88 degrees divided by the sine of 40 degrees. Or, because remember, the only thing we're changing between these two triangles in reference to angle B is B was 88 degrees, or it could possibly, angle B is 88 degrees, and angle B could also be 12 degrees. So I'm going to now replace 88 degrees in this ratio with 12. And we're going to input these two ratios in the graphing calculator to determine the two possibilities for the measure of angle B. And I believe we are rounding to the nearest 10. So let's do that. We'll start with 26 times the sine of 88. So I'm going to put parentheses, 26 times the sine of 88, close parentheses, divided by the sine of 40. And we get 40.42, and that 2 will tell that 4 to stay where it is. So 40.2 is one of our choices. Now let's go in and change 88 degrees to 12 degrees. I'm just going to simply go in and change that there. And it is going to be 8.40. The 0 tells the 4 to stay where it is. So the two different measures for B, which is side AC, is 40.2, or AC could equal 8.4. Okay, so 7 and 8 kind of removed this information from the original context, and now number 9 takes the context of our real-world scenario. Sorry about that. The context of our real-world scenario, and we're now going to apply the law of sines to it. So number 9 says 3 radio towers are positioned so that the angle formed at vertex A is 65 degrees. So we can go and draw, and again, I'm drawing all these angles, what looks like the same measure, but just for the sake of the problem, we'll just say that angle A is 65 degrees. And the distance between tower A and tower B is 28 miles. I'll go ahead and draw another possible angle A, since there are going to be two possibilities here. And the distance between tower A and tower B is 28 miles. So following the path of this ray, we'll just say that this is now 28 miles. And we'll say that this is B, and we'll do the exact same thing here. I like to have a diagram of my information. And the distance between tower B and tower C, which tower C is going to be somewhere over here, is 26 miles. And so this is the ambiguous case. So we could either draw it such that this is 26 miles and C will be somewhere on this ray right here. Or we could draw it such that this is 26 miles and C is located here, still on the same ray that A was. So it says, what are the two possible distances between tower A and tower C? So again, we're finding opposite of angle B, we're finding lowercase b in both of these scenarios, just like we did on 7 and 8. It says, draw a diagram to support your answers. Here we go. And round to the nearest whole number. So they finally have given us directions here, so we'll obey those directions. So in order to find this distance here, we need to find the measure of angle B. Well, in order to find the measure of angle B, we need to find the measure of angle C. So let's start by finding angle C, just like we have done on these previous two problems. So to find angle C, we'll start with this acute triangle. You could start with the obtuse. It's a little bit more complicated that way, but we'll start with as if it was an acute triangle. So we'll start with the sine of A over its opposite side. I'll go ahead and label these to help those watching. So this is lowercase c, this is lowercase a, and of course we've already labeled that b. So we're going to write the sine of A, which angle A. So the sine of angle A is, the measure of angle A is 65 degrees over its opposite side, which is 26 miles. And again, if we're solving for angle C, we should definitely use the sine of C since we have its opposite side, which is 28 miles. We're going to do a little cross multiplication here. So we get 26 times the sine of C equal to 28 times the sine of 65 degrees. And to get sine of C by itself, we're going to divide both sides by 26 so that we get the sine of C is equal to 28 times the sine of 65 degrees over 26. Now, to find actual angle measure of C, we're going to take the inverse sine. So running out of a little room here. So the inverse sine of this ratio, 28 times the sine of 65 degrees over 26, will yield the measure of angle C. So C, or at least one value for angle C. So let's plug in this ratio to Desmos. So the sine inverse of 28 times the sine of 65. So sine inverse, parentheses 28 times the sine of 65 divided by, I believe it's the sine, just of 26. And we get 77.42, but they did tell us to round to the nearest whole number, so we will, that 4 will tell that 7 to stay where it is. So that one possibility for the measure of angle C is 77 degrees, and we'll go and put that in this acute triangle. And again, to find this other possibility, we're going to take 180 and subtract 77. And we get 103 degrees. So now that we found two possible measures for the angle C, we're going to find the other two possible measures for angle B so that we can find the side opposite of angle B. So on this acute triangle, we'll take 180, subtract 65, subtract 77, and angle B could be 38 degrees. Likewise, on this second triangle, we'll take 180, subtract 65, but this time subtract 103, and we'll get 12 degrees. So we have two possibilities again for angle B, 38 degrees or 12 degrees. So now that we found two possible measures for angle B, we can now find the opposite side of angle B. So again, we'll definitely use the sine of angle A in this situation because we have that angle and its opposite side. I'm actually going to do the work up here. So the sine of angle A, so 65 degrees, over its opposite side, which is 26, is equal to, now that we have a possible measure for angle B, we'll plug that in for sine of B. Not sure what happened there. One sec. There we go. So the sine of 38 degrees for our first possible triangle over its opposite side, which we're finding, which we call lowercase b, which is technically the distance from A to C. So we'll do a little cross multiplication here. We'll get 26 times the sine of 38 degrees equal to b times the sine of 65 degrees. Sorry for running into that problem. And since that's b times the sine of 65, to solve for b, we'll divide by the sine of 65 degrees and find that b is equal to 26 times the sine of 38 degrees over the sine of 65 degrees. Now remember, we actually have two options for the measure of angle b, which is 38 degrees in this equation. The other possibility is 12 degrees. So we're going to go and replace the second option for b. We're going to replace that with 12 degrees. So we're going to write b is equal to 26 times the sine. Instead of 38 degrees, we'll insert our 12 degrees over sine of 65 degrees. So we'll go and find the two different measures for lowercase b. So using our handy dandy calculator, we're going to do parentheses 26, I believe. Let me make sure. 26 times the sine of 38. Close parentheses because we want to make sure it multiplies that first, divided by sine of 65. And we get 17.6. Now they did tell us to round to the nearest whole number, so the 6 in the 10th place tells the 7 to round up to an 8. So when angle B is 38 degrees, the measure of its opposite side is 18 miles. Well, now let's evaluate when the measure of angle B is 12 degrees. So I'm just going to simply go in here and change 38 to 12. And now rounded to the nearest whole number, the 9 tells the 5 to round up to a 6. So the two possibilities here for the distance between Tower A and Tower C is 18 miles or 6 miles. So I don't know if we can actually, we'll put that in. So AC could equal 18 miles or 6 miles. So that is, number 9 is just putting the law of sines, the ambiguous case of the law of sines, back into the context of the real world problem we saw at the beginning. So that is the end of lesson 23-2 practice. Lengthy material, but hopefully we're learning the process and why we use the process that we're using. Hope that helped. Thank y'all for watching.